something to protect an area. Okay, so I will show you an example. Okay, so I will go back to talk about this guy. Okay, the example is like this. Let's say I create a function. Okay, the function will do only one thing. So this is the value function. The value function is to try to modify a shared object. Every time it will add 1 to the shared object. Okay? And there is a limit, let's say 20. Okay? 20, when it's reached 20, then every thread should die. Okay? So this is very clear that mutual exclusion is needed, right? One guy is modifying it, another guy should stop. So how can you implement it? By looking at it, you kind of get an idea. By removing all the prefix keyword, you kind of understand what it is. There is a loop, okay? And the loop will eventually break because it reached the maximum value, okay? So first problem, how can we set up shared object, okay? In prefix, it's very easy. So that's why threading is the very important part in computing. And I have a little secret is, until I go to PhD, okay, I kind of find ways to avoid using threading and still can complete my work, okay? But before, that means that sometime after I graduate from a bachelor until I enter PhD, during that years, I cannot avoid using prefix, okay, or any other threading model, okay? So that's why here is very important concept for you to understand, okay? So how can we guarantee that we have some global resource? Okay, sorry, I should use an editor. Okay, it's not good. So the shared object is actually a global variable, okay? And global variable is automatically shared among all threads. So when I create a thread, I don't need any special control. So this is a thread function. This thread function, I usually call it do your job. Okay. So the thread function can touch this share. Okay. Now what are these guys? Mutex lock, Mutex unlock. So this guy are the, you can consider it as a binary semaphore. Binary either on or off. Okay. When it is locked, you want to lock it again, you will be blocked. Okay, remember, that is, you are inside the toilet. Someone still want to go in, then that guy will block outside the toilet. Okay, and here is the simpler version, very simple, no semaphore keyword. Just call prefix mutex lock, and give me a mutex variable, then I can lock it. And when you go out, you want to unlock. Then you will use prefix mutex unlock. Okay, so you can see two unlock because why? Because whenever we inspect, not just update, okay, inspect a shared object. Take a look here. Before I inspect its value, I already have to lock it. Okay, because while I'm inspecting it, maybe someone modified it. So I have to lock and then inspect. If after inspect, I know that I have to update it. Okay, I do the update. If I cannot do the update because it's already reached the maximum point, then I will quit the loop. So then I will unlock and then break out of the loop. Or I unlock and then sleep for some time. I don't know for how many, because it's a random %2. Either you sleep 0 or sleep 1. So either you sleep or not sleep. And the maximum time is 1 second. So this is the program. And how to use this mutex? The mutex, when you want to use it, is a mutex equal to prefix mutex initializer. Okay, but in other languages it's different. In Java, there is no mutex. Okay, Java has no mutex. How many of you have written Java before? No. C#? Oh, good. So have you ever heard of a keyword called synchronize? Okay. what happened? C#, now synchronized. Okay, this is the keyword copy from Java. Java used the keyword synchronized for more than 20 years. Okay, so I zoom in for too much. Sorry. Synchronized method. So what is C# version of Java's synchronized keyword? Okay, people ask this question, huh? So what is synchronized? Do you know? Or how many of you have heard of this? No one. Only you. So have you used it? No, but you heard of it. Okay. So actually, this is the OO type, or somebody don't consider OO type, a special defense mechanism. Yeah, really a defense mechanism for an object. Okay? When an object has a synchronized method, that means that whenever you touch that method, you are the only thread that can touch that method. Another thread wants to touch that method, and the method is called synchronized, you will be blocked. So this is automatic mutex. Yeah, the mutex is on the method side. When you call the method, you automatically call lock. When you return from the method, you automatically call it unlock. So this is synchronized. Okay, synchronized is also happening in C#, in Java, other languages I don't know because they may change the name. Okay, some call it monitor. Okay, so this is synchronized. And in C really low level, it explicitly tells you that there is a guy called mutex. Okay, so this is the mutex. Now let's see how the program runs. This time is crazy. I love this demonstration. So we can choose something. You can choose the maximum number, and you can choose the number of threads. Okay, so why are you laughing? How about I choose 200, but 20 threads. Okay, sorry, the display is not good. Hey, come on. 200. What happened? 220. Okay. So when I press enter, you will see the 20 threads get created and try to update the same value over and over again. So it is just popping up something. Okay, we wait for some time. Okay. So then every thread will die and report for how many times it contributes the numbers. Okay. So by average, each thread will contribute around 10 times of the plus. Okay. So approximately, this is not very good. Some get only 5. Okay. Most of them get around 10. 9, 11, 13. Okay. So you will see something like this. Now, you may ask the questions. Okay. The question is not about this 200. Yeah, making it bigger, no problem. Okay. What we are sacrificing for making it bigger is the time, right? We have to wait. Okay. And let me do an easier version first. 2 and 10. Okay. So you will find that no 2 threads updates will report you the same number. And that is not proof, okay, but show you that actually they are incrementing the global variable. There's a global variable, and it's incrementing, and it is protected, and so happen share fairly. Now, what do you think? Can I launch 300 threads? Yeah. No problem. This is my computer. Yeah, maybe you try in your computer as well. Okay, let me make 1,000. Okay. Go. No problem. 300 threads, no problem. Let me try something bigger. 3,000. Yeah, make it bigger. Can I launch 3,000 threads? What happened? Does this seems to be normal? Can you see the termination signal here? It seems there's something wrong. Really something wrong. Yeah, you cannot see what happened, but it just died. The entire program just died. And when it dies, it says something around 300 something, and it dies. Okay? Is it because I'm creating too many threads? Maybe yes. Let's try to have fewer threads, 400. Now, this time we see something. What is that? Okay, LK memory. Okay? So, every computer has this problem. They have some limit. Okay? And this is the first time that you see some limit that can be challenged, and my machine didn't crash. Okay, previous fault, I crashed my machine. Okay, infinite zombie factory, I crashed my machine. This time I don't crash my machine. Oh, by the way, why is called cannot LK memory? Okay, it's just because of the thread. The thread creation. Okay, here. It's actually creating one more orange box. Okay? So let me tell you how to calculate the limit. Each orange box has approximately 8 megabyte. Okay? 8 megabyte for each box. And how many memory that we can make use of in a typical 32-bit CPU? The size is 3 GB. Okay? 3 GB. So 8 megabyte is 2 to the power 23. Okay? 3 GB. GB is what? 2 to the power, no one knows? 30. Okay? So I swapped the order, sorry. 30. 23. Okay? That means 3 times what? Am I doing some calculation wrong? There seems to be something wrong here. Okay, so this is 2 to the power 7. So many. Oh, right. Approximately, yes. Okay, so this is 3 times 128. So approximately 300 something. Then we will run out of threads. Okay, we'll run out of threads. And this limit is only because we are running on 32-bit CPU. If you are running on 64-bit CPU, okay, this is not 30. If it is 64-bit CPU, it will be 60 something. Okay, this something I think when I die, I cannot challenge this something. Okay. Yeah, you know, how come we are manufacturing so many RAM, okay? Yeah, it's not possible. Okay, but now we already can tackle the 3 GB problem. So we can try and allocate all the memory, and what you have seen just now is I really suck up all the memory because of creating too many threads. Okay? So that means that when you go to work later, your boss tell you that, please do some high frequency trading. Okay, they are using C++ threading library. Okay, and if your boss knows something, they will give you 64-bit CPU, 64-bit architecture. If the boss wants to play you, okay, will give you a 32-bit. Okay, and you should say it loud and clear that you know nothing. Okay, take OS course, please. Okay. So this is about a threading number, and the library code itself is not very hard to understand. Just the log and unlog, and we have 2 ways to initialize it. Either you use this way to initialize, or you just pass in a pointer to that guy, and then call init function, no problem. Now there is something much harder to understand, really much harder. Okay, because it is a new type of synchronization mechanism. It's not done by semaphore. Okay, I believe that since I didn't write any C#, I hate Microsoft. Okay, I don't like C#, but when I observe their libraries, okay, I think that they are the same as Java. This is the model for Java. Maybe for C#, let me guess. Whereas C# has this kind of thing. If yes, that's good, then you can write C sharp wait and notify. Equivalence. All. Right. Then you are learning the correct model. Okay. So this model also fits C sharp. Okay. So what is this model? This model is kind of hard to understand. It's not semaphore. First of all, we model this problem. What is this problem? Producer consumer. Okay. So yeah, let's do this. Imagine that you are the Mr. Consumer. Okay. Now stay close with me because this is new model. This guy wants you to DQ. Okay. But the entire story just started. The producer is still sleeping, didn't do anything. So when you do the DQ, what you should do? You should block, right? There's no space inside no space, many space, but no occupied slot, no items inside. So this guy do DQ, will go to sleep. Okay? So this is what we want. But how about programming? Programming is you know that it is empty, so you have to sleep, but who wakes you up? In the semaphore scenario, we set up a semaphore to do it. Okay? The semaphore is you wait for the semaphore, okay, and then someone up the semaphore, you will wake up. Now here it's not done through a semaphore, but go through a variable called condition. Okay? And in C sharp, the variable is called monitor. Okay, so this is called monitor model. Okay, so the monitor or the condition are just function as the same. You wait for someone to notify that guy, and it's not this guy, it's this guy. Okay, this condition variable. Okay, when I find that someone notify this variable, then I will wake up, just like semaphore. Someone up the semaphore, I wake up. Now here is someone notify, send some signal to this condition variable, then I will wake up, and the scenario is like this. Let's say I want to enqueue, okay? Then I will signal the empty condition. I don't know how many people wait for the empty condition. I don't know. Maybe 10 consumers there. Okay, 10 consumers waiting for this condition, no problem. This will broadcast to everyone who is waiting for it. Okay? And in C sharp, in Java, they have to say, Java is, I know Java better, okay? The object, okay, is the guy that have a synchronized method all the way, okay? But when you are afraid calling that method and you want to sleep, someone has to notify you. So that's why when I Googling, I find that this is the Java version. Notify. Then the foo is the condition variable. Okay, and when I notify all means that I don't know how many threads are waiting for the variable. I just broadcast them all. Okay, in C sharp it's called pulse. Yeah, kind of strange as the name. Okay, so the reverse is you have to do it in the same manner, but you set up another variable. I call it foo. Okay. Yeah, because it's full, okay, I cannot move on, okay? So I will go to sleep, and when I go to sleep, please, someone notify this full condition so that I will wake up. And when you write program, I will go ahead to the program first, okay? It just looks like something shorter than the semaphore version, but totally different concept. The concept is like this. Let's say for the producer first have to lock the entire data structure. Okay, so you will call prefect lock. And what happens is always run out of battery. Call the prefect lock, and then lock the mutex. No one can touch the global data structure. Then you will check whether the buffer is full. If it's full, then you will wait for this full condition. You say you wait for it. Okay, someone. If you find that the buffer was full, okay, so you are the consumer. So the buffer was full, then signal this guy. So this form pair. If it has become a C#, then it will be the monitor dot what? I remember the pulse. Dot weight. It's just the same as Java. This will become monitor dot weight, and here just copy and paste the same code will become monitor dot pulse. Okay, so here is called signal. This is called weight. Okay. Then in other is the reverse. Okay, the reverse is this guy want to consume item is find nothing. Find nothing. What you should do is to go to sleep. So when you go to sleep, you will call based on the empty guy. Okay, the empty condition variable. Okay. So why I call it condition variable? Because the type is really called condition. Prefix condition type. Okay. But I know this is too tough, so every year I don't test this in the final exam paper, okay? But it's really important for you in understanding other programming languages, okay? Other programming languages implement this way, okay? So I will show you the implementation code, okay? So this is implementation code. I have the producer consumer code here. Producer consumer. I make it become a very big function because I have to draw it beautifully, so I have a very big drawing function. If you don't want to understand what I'm doing, just give it very long, very long. You can see very long drawing function. Keep on drawing, finish drawing. Okay, so this is the producer. Yeah, so many lines for drawing. How many lines? Wow, 100 lines for drawing. Okay. So now here comes the producer. The producer first have to lock the data structure. So lock the data structure. And I use the implementation of a queue, okay? So it is a queue is full function, okay? You don't need to care. Just trust me that it is a queue data structure is full function. If it is full, you are the producer. Then what should you do? Just say that I will wait for the condition called full. And you have to pass in a mutex because you are currently locking a mutex. Okay? And this condition wait will unlock it for you so that other people can take the lock. Okay? If you are coming back from this wait call, then you will go on to the next code. But let's say you are not full, you don't find the buffer is full, you find the buffer is empty, then you will signal another guy. Just the same thing happened inside my pseudocode. Okay? And after this, I just here is the produce of the item inserted. Okay, this is enqueue, right? I produce an enqueue to the tail. Okay, and the tail go to the next slot. Okay, and call the drawing function and unlock the mutex. Okay, so the producer is like this. The consumer is just similar, and the end result will be something like this. Okay, so last lecture I showed you, but let's wait until it go to the full buffer scenario. Okay, so here's a full buffer scenario. Okay, so you will see when the buffer is full, okay, you see this guy is originally having here is no slot here means that it don't produce anything, but here is a consumer has consumed something. Really, I cannot see it. Right. This consumer is consuming something. Okay. Then this guy produced 2 items in a row, but because I protect it, okay, I don't want to disrupt my drawing, so I should say some printf saying that, oh, I go to sleep, okay, but I don't do it. So here is the moment that if you have next item to produce, you cannot produce because the buffer is full. So you will go to sleep, and this guy continue to consume. So you will see the sequence. This guy sleep for a very long time. I don't know why it so happened. The scheduler is doing something bad. And you can see something like this. So this is the producer-consumer model. Okay. Maybe next time I write a Java version, then maybe I give you a task to convert it to the C#. This is very easy to write Java. I think I just need 30 minutes and then complete it, if it's for Java. C#, I don't know, don't ask me. All right, one more important thing, okay? You learned some IPC protocol in previous chapter, but it seems that prefect don't like semaphore, okay? Although you can find a man page called man page semaphore.h, no. Semaphore, no. I remember there's a semaphore.h. Semaphore.h. Yeah. So it actually has a semaphore.h, but don't use it. Okay, it's not for prefect. Okay, it's for some other things. So what can you do if you cannot change the current IPC based on semaphore to the IPC based on the C# model? You cannot do it. What you should do, actually you can implement the up-down call by yourself. It's very easy. I tell you, it's very easy. How can you implement it? Okay, so imagine that we construct such a structure. Okay, I use these three guys to represent one semaphore value. Okay, so this value means the semaphore real value. Okay, so let me initialize this to 1. Okay, then you can call down. So why you can call down? As if you are locking the semaphore. The semaphore has to lock, right? Because it's just an integer. So you have to lock it, and then when you lock it, you can inspect the value now as if it is a structure. So I use this symbol because it's a structure. Check the value. If the value is 0, remember you can flip the part 5 nodes if you have now. I call this line special sleep. Yeah. See, this is really a special sleep. A special sleep is based on condition weights. If you want to implement it in C#, that means it become monitor.weights. Yeah. Then after somebody wake you up, okay, you have to keep on checking because there may be other friends raising for the semaphore value. So happen that you have bad luck. When you wake up, somebody take the value that incremented, so you find 0 again. So I put a while here, just like what I described while I'm talking about the implementation of semaphore. Then decremented, unlock. Up call, do you remember that? When you have an up call, you find that it is 0, then that is the time that you have to wake up someone in the waiting list. Here it is. So that's why I say that I inspect some of the code and give you the pseudocode in the part 5. And you think that the pseudocode is very hard to understand. Yes, because this is really some other model implemented it. Okay. So this 3 guys act together is actually your up-down code. You can now implement in C#, in Java, in Prefect, because they are all following this same model. Okay. Last but not least, thread safety. I still have time. I will spend first 5 minutes, okay, and tell you what is thread safety, and I left the solution for thread safety in next week. Okay. So it so happened that a few years ago, okay, I have some friend working in Microsoft. He come to visit me, but so happened that that day I have to teach OS. So that guy is doing some crazy stuff, sitting at the back, okay, and watching me teaching OS. So happened that I teach thread safety, and he mentioned that, good, you tell all the people that thread safety is very important because he is debugging thread safety problem in Microsoft. So what is thread safety? Let's take a look. Okay, how many of you didn't use string token in assignment 1? Everybody use string token, right? So that means this is something that makes sense because you have used it. Can you guess what is the implementation of string token? How string token is implemented? Do you know? Can you guess? Yeah, you guys is talking means you know something, right?
After the first time you make use of a string token, and the next argument you put into this function is none.
Yes. Yeah, this is how you use it. But can you guess how it's implemented? Now, what you have mentioned is there are 2 guys, right? The delimiter I should say there's a string, okay? I have the string. I have the delimiter. Okay, delimiter. The first time, I have this guy. But the second time, the third time, I don't need it. Why?
So when the first time you call it, it just goes through the string and replace all the part with the delimiter with the.
But how come the second time you call it, it knows that you're talking about the same string?
Because it already points.
Yeah, it's already.
Points to the last part.
How is already point to it? How?
I've read about the implementation.
Yeah, you just think you don't need to read it. Yeah, you can emulate how it's being implemented. Look at this. Look at this diagram. Can you guess from this diagram? Global variable. Yeah, why not? The function itself hides some global variable, or just malloc, no problem. Global or malloc, they just try to keep track of the pointer. The string is pointer, right? The pointer address the last time you use it, and save it to that purple box. Okay? So if that's the case, what do you think if I make it into a, I shouldn't call it make it. I call string token is a multi-threading environment. That will be colorful. Okay, so let's take a look at my program. Prefetch string token. Okay? So basically I pass two different buffers. Okay? Previous discussion I already tell you that, okay, I cannot pass the same pointer or same piece of memory to two different threads. So I create two buffers. Okay, believe me, this is the defined saying two. We can make it free, no problem. Okay, so there's two. Okay, the string max will be 255 character, just like what you have in our assignment. So it makes sure that I'm using two different buffers. Then I pass this buffer with some modification. I want to add some different character, like the first thread will be called thread 0 says Linux is a cooperating, cannot see it. Operating system. And then at the end, I also put an I here so that I construct this string with its identity 0. Second time, I will insert 1 and 1. 1 is the end, 1 is the beginning. So that you will see the two strings are totally different and on different piece of memory. Okay, that's very important. In using threading, you have to do it. Now, what I'm doing is inside this thread function, I have some special things. Inside this thread function, what I'm doing do while loop. First time calling, use the input that you pass me. Just do a casting. Okay? So as simple as what you have been used for the entire assignment 1. What next is I keep on calling it in a while part, okay, to get the token. Now, as if you are doing the same thing in your assignment 1, but this time it's a multi-threading environment. Okay, so get the idea. I pass data perfectly. I implement the code perfectly. Let's see the results. String token. What can you say about the result? What would you expect? You should expect that I put down two different strings. So what are the two strings? First string is this guy. Thread 1, I start with the input Fred 1 says Linux is a cool operating system 1. So make sure that full of 1 there. Okay? You see there is another string. Fred 0 says, I start with the input. Fred 0 says Linux is the cool operating system 0. And take a look at the output. Okay? So what is the output? The output, let's refer back to the code again. I will print out every token inside the do while loop. When I get 1 token, I print it out, get 1 token, print it out, and I also incrementing the token counter called I. Okay, I is a token counter. Okay, no problem. But there shouldn't be something like this. It should at least showing Linux appear twice, operating system, operating keyword appear twice, system appear twice, because I fit in 2 different strings, 2 different threads. Each thread should have 1 do while cycle over the token, right? Tokenization number 1, tokenization number 2. How come I only have 1 piece of string saying that Fred 0 says Linux is a cool operating system 0? Where is the 1? Where is the 1? And you already know the answer. When I ask you, hey, what is the implementation inside string token? The implementation of string token is using a global variable to store the first time you call the string, right? You first time call the string, you pass in something, and the next time you don't need to pass it in. It means that there is a global data structure shared by those 2 threads. There are 2 threads share this global system, and this global thing, okay, you allow 2 different threads to call it without any protection. And there is no 2 pieces, just 1 piece. 1 piece of this global variable. So when thread 1 call it, let's go to take a look at my output. When thread 1 call it first, okay, you set the variable, the global data structure, having the string about thread 1. But the next time you call it, it's actually from thread 0 here, okay, thread 0. So thread 0 overrides the global data structure. Okay, override global data structure so that the old data structure by thread 1 gone. This is thread safety. And we actually don't call it thread safety. It's called, this function is thread unsafe. Okay? When you put a library code runs perfectly under the fork environment, right? You are doing fork in your assignment 1. But you put it in a multi-threading environment, it all dies. It is called thread unsafe. Okay? And my friend working in Microsoft, I can say it loud because it's already several years ago. Okay? He is debugging Vista. Vista full of this kind of bug. He said, this kind of killing him, okay? He really want to quit this job, okay? Very hard to find out, right? Because every people call those calls as if they don't understand whether there is a thread working on it or a process working on it, right? You design a function call, you never thought whether thread or process, you don't know, okay? So, how would you solve the problem? I will tell you the solution next time. And actually, the solution is not a solution. Okay? The solution is don't call string token. Call another thing. Okay? And the next page you will see, yeah, don't call string token. Call another thing. Okay? So let's stop here.